So let's attempt to solve this system of equations using Gaussian elimination. We know what the solution set is. We solved it at the end of the last video. But we'll use our Gaussian elimination, and then we'll show what it was that we're doing here. Okay, so our first step is to create our augmented matrix. And it's 1, 2, 5 for the top row, 1x plus 2y equals 5. 3x minus 1y equals -6 goes in the bottom. Okay, remember that we're only putting the numbers in there and we're not putting any of the variables. Now the important thing to remember is if you want very many points when you're doing this for me, then every time you move from one step to the next, you need to write down and tell me what row transformation you've done there. So when we start out, it says we need to get a 1 in the first row in the first column. Okay, so that's up here in the top left corner. And since there is a 1 already there, we can check that step off of the list. Okay, occasionally, we have, about half the time, we have a problem that starts with a 1x in one of the equations, and so we can always honestly just put it on top if we need to. The next thing we want to do is make a 0 underneath it, the rest of column 1, which means instead of a 3 here, we want to get a 0. Okay. Now the important thing to keep in mind is once we have a row the way we want it, we're not ever going to change it again. So the 1, 2, 5 up here, we're going to leave it 1, 2, 5 when we move over here. Now if I can, I'm going to try to combine these two slides together and get these row transformations where we can see them. But remember, when we're trying to make that number into a 0, what we're allowed to do is only the 3 things from this list. Okay. So these are the only 3 things we're allowed to do. So once I have a 1 in the top left column, I need to make a 0 here. If I had a 0 in the rows, any of the rows below this, I could slide them up into that place. Okay, of course this is the only other row I'm working with, so that won't work. I can multiply any row by a non-zero constant. Multiplying everything times 0 would make a whole row of zeros there, and that actually takes information away from us. It doesn't help us move forward. So that means we are looking at this bottom transformation here. And if we think back to what it is we're really trying to do with this system, we're trying to find the solutions, the points of intersection on these lines on the graph. And we said we're really just doing elimination. I think I said substitution in the last video, but my tongue was wrong. We are trying to do elimination, but we're always eliminating the x's. So if I want to eliminate the x's here, and I have positive 3x on the bottom, then what do I need to do to this top equation in order to create an opposite here in front of my x's? We would need to take that top row times -1. Okay, so R1 means row 1, and I'm going to indicate that I'm going to take that times -3. After we multiplied that entire equation through by -3, then we added the 2 new equations together. I have a lot of room here to write, so I apologize for the mess, but that says -3 R1 plus R2. So what we're going to do is multiply this equation times -3. We're going to add that new equation to this equation that already exists. And what we're going to get for our answer, we're going to replace this bottom row with those coefficients. So I'm going to be very literal on this first example. We're going to take -3 times the 1 that's already there. And then we're going to add it to the number in row 2, which is positive 3. -3 plus 3 is 0. Then we're going to do it again. We take -3 times whatever's in front of the y, and then we're going to add it to the coefficient down here on the bottom row. So -6 plus -1 is -7. And then we do it with our last number here. Negative 3 times the constant is 5. And then we're going to add it to the constant in the bottom equation. Negative 15 plus negative 6 is negative 21. Alright, so now my top row, we said it was the way we wanted it. We now, in the second row, first column, we now have finished up with our 0. If there were more rows below, we would need to do the same idea again over and over until we had zeros all the way to the bottom. So then our next step, we want a 1 in the second row, second column. We come down the diagonal and we want a positive 1 there. Okay, going in order, this is what we hope to be able to do. If there was a row below it that started with a 1 right here, we'd move it up in its place. But again, we have no rows. So then we say, can we multiply? And when it says multiply, you can also think of it as division. Multiply or divide by anything other than 0 to make a 1 there. So if we take everything in row 2, and we divide it by negative 7, we should be able to do what we need. 0 divided by anything is 0, or 0 times anything is 0. And the big thing we have to make sure of is once we have a 1 where we want it, we don't ever do anything to screw that up again. Okay, once we have our 0 where we need it, we're not going to do anything that screws up that 0. But 0 divided by 7 is still 0. Negative 7 divided by itself is positive 1, which is what we want. And negative 21 divided by negative 7 is positive 3. So we would continue this process. Now I'm done with row 2, and if there were rows below it, I would make zeros all the way to the bottom. And then I keep going down the diagonal, again, either until I hit this bar or I run out of rows. Now there is a way that we can keep going with this that shortens this last step a little bit, and if you've seen and done that before, you can keep going. But for me, 1, 0, 1 is as far as you have to go if you're going to use this process and demonstrate it on a homework quiz or test. Now from here, we do what's called back substitution, which means we start on the bottom row, and we don't write x. We start on the bottom row and we turn that row back into an equation. So these were our x coefficients and our y coefficients, and this was our constant. That bottom row now says we have 0 x's plus 1 y equals 3. My top row says x plus 2y equals 5. And so now I know what y is. It's a 3, so I replace the y with 3. And then in one step, I have my x. From there, I can write my ordered pair. For my solution set, it's just the single point of intersection, negative 1, 3. If we look at what we did here, and we compare on the left, we said we were going to eliminate the x's, so we multiplied that entire equation by negative 3 and got this equation. Then we added it to that equation and got negative 7y equals negative 21. Notice if I compare that, if I can draw across the boundary here, right here, negative 7y equals negative 21. Okay, so in all this step from here to here to here to here, I did that. I'm going to use the words in my head. I physically wrote them on the paper for this example. But I took negative 3 plus 3 and got 0 for the x's. Negative 6 minus 1 more is negative 7y. And then negative 15 minus 6 more is negative 21. Then I said if negative 7y equals negative 21, notice next we divided both sides by negative 7. We divided both sides by negative 7. That gave us our y. Now I know what y is. If I know what y is, I can back up one row and I can find x. The next video, we're going to do some more details on this. And we'll do some more examples, I'll say, instead of details. And you can follow along if you're still interested in continuing.